Welcome, dear students, to the new video on process concepts. In this video, we will be covering about the operations on the processes, where we'll be discussing about process creation, process execution, as well as process termination. In addition to this, we'll also be covering about inter-process communication. So let's begin with the process creation. We know that processes can execute concurrently. So the processes can be deleted as well as created dynamically. A process can create several new processes. So the process which creates another process is called basically a parent process, and the new processes which are created are called the children processes. So basically, further these children processes can also create another processes. So we can have an image of something of this kind. That is, suppose this is the parent process. It has gone for creation of some new processes which are referred to here as their children processes. Let's say P1, P2, and P3. So these P1, P2, P3 are the children of the parent process P. But these P1, P2, P3 can further create new processes. Let's suppose it went for creating a child process named as C1 or another one C2. This is also gone for creation of a new child process, let's say named as C3. And generally one more thing is over here, that is the processes are identified and managed by process identifiers, that is PID, known as PID. So each of these processes is having a unique name so that we can differentiate one process from the another. So for example, over here if we see, total of 7 processes are over there. The parent process was P, having 3 children processes, and further these 3 children have gone for creation of 3 more children, though P2 has not gone for creation of any of the children, but process P1 created 2 child processes, and process P3 created 1 child process. So total of 7 processes are over here, and each of these processes will be having a unique process identifier. Basically, the job of the process is to do something. It is supposed to perform some task, and to do that task it needs some resources. The question arises that from where will the resources be allocated to these children processes? Now there are two possibilities over here. One possibility is that each of the children will demand the resources from the operating system. Other possibility is that the children can gain access to only those resources which are already acquired by its parent. That means this process P, suppose, is having some set of resources with itself. Fine. So these children can only gain access to the resources which were already acquired by their parent. Outside this set of resources, these processes won't gain any access for the additional resources. Fine. So a child process basically may obtain its resources from the operating system, or it might have to restrict itself to a subset of resources allocated to its parent process. So in that scenario, a parent needs to distribute its resources amongst its children. If this is the case, then indirectly the parent is prevented to create too many child processes, because if it happens, this will put the burden on the system. So what I mean to say over here is, suppose the children processes can gain access to resources, that is they can put the request for resources to the operating system. So in that case, what will happen? Suppose there is some malicious process which is creating so many child processes over there in the system, and is basically putting the burden on the machine. So to avoid that thing, basically, if it is the parent who is supposed to fulfill the needs regarding the resources from its own, in that case it will restrict itself from creating unnecessarily child processes. The question arises how these processes will execute. So there are two possibilities over here. The first possibility is that both parent and the child processes can execute concurrently. Both P as well as P1, P2 and P3, they can execute concurrently. The second possibility is that parent cannot execute when its children are executing. So it keeps itself in a waiting state and it waits till the time all its child processes have completed their job and they have terminated. Then only the parent process will continue with its job. Now, if we talk about the address space with regard to the new process, so uh, basically the child process is a duplicate to a parent process, that is it has same program and data as that of the parent. This is the first possibility where I'm saying that the child process basically is a duplicate of the parent process. If that is the case, uh, it means that it has, that is the child has the same program and data as the parent is having. The second possibility is that the child process has a new program loaded into it and it will execute accordingly. So below this we have shown a few system calls with regard to the creation as well as execution of the processes. So the question arises, how can a parent process create a child process? So for that we are having a fork system call. So whenever a parent process or whenever a process calls for a fork system call, in that case it will be requesting for creation of a new process. So with the help of this fork system call, a new process can be created. So once the process has been created, so thereafter that process or the child process needs to execute. So for that another system call is over there, that is exec system call. The exec system call basically loads a binary file into memory and start its execution. So I would like to conclude over here that fork is basically used to create the new processes, whereas exec system call is used for execution of the processes. So now let's move forward. Uh, the next thing is about process termination. So whenever a process completes its task, that is it has executed its final statement, then it asks the operating system to delete it by using the exit system call. So what I'm saying over here is, a process was assigned some task. Suppose that task has now completely been done. That is the last instruction of the task is executed and now the process wants to terminate. So in that scenario, the process makes an exit system call and after to the operating system so that the process can terminate. Now in this scenario, whenever a process terminates, whatever resources are held by the process, they all are deallocated. So in case the process, that is if it was a child process and it has done its job, so whatever resources were held by this child process, in case they were acquired through its parent, so all those resources are returned back to the parent. And in case the resources were acquired from central pool, that is from the operating system, in that case all the resources are returned back to the system itself. So now there is a question that whether the parent may terminate the execution of all child processes. Yes, it is feasible. Suppose the processes are the child processes are executing. So question arises, can these child processes be stopped in between? Yes, it is feasible, but in normal cases it is it can't be done by any other process, but only the parent of that child can terminate the processes. So for that, it can be done using a abort system call. So now the question arises: why would a parent would like to terminate its children before they have done their job? So there are few possibilities over there. The first possibility is that in case the child is demanding a large number of resources, and the parent is unable to fulfill the demand of all the resources which are requested by the child. That is, if in case the request exceeds certain levels, so in that case the parent may abort the child process. Second possibility is that suppose some particular task was assigned to the child process by the parent, and in case as of now the task which was assigned to this child process is no more required, so in that case also the parent can abort the child process. Another possibility is that uh, the parent itself is terminating now. So, in some scenarios, the OS does not permit the child processes to continue in case parent is no more in existence. So, if the parent is exiting, in that case also all the child processes would be terminated. I hope you got the point. So before we move to the next slide, I would like to summarize the things. A process can cause termination of another process by using an appropriate system call. For example, one of the system call is abort. Apart from that, there is one more system call, that is terminate process. It's this system call through which the process can be terminated, that is terminate process. This is the another system call. Fine. Basically in Windows, and usually this system call can be invoked only by the parent process who wants to terminate its children, because if any other process uh, is given this liberty to basically terminate any other child process, so in case that process is misbehaving application, so it will try to kill other users processes without any reasons. So in such a scenario the system would behave in an abrupt manner. So, uh, what I've told is a, uh, a parent can basically terminates its children. So, whenever a parent wants to terminate its children, it should be aware about their process IDs, and it can put a request for a bot system call with regard to a particular process, and that particular process who is the child of the one parent who has gone for an system call called abort will lead to termination of that process in between. Also, I have told you that some systems do not allow a child process to exist or continue if the parent has terminated. So in such cases, basically, or in such systems, if a process terminates, maybe the termination is normal one or it's an abnormal one, then all its children must be terminated. So this phenomenon or this case is referred to as a cascading termination. This is referred to as a cascading termination, that is, all children's, grandchildren's, etc. are terminated, and if that is the case, this termination is initiated by the operating system itself, because the OS does not permit the children to continue in case the parent has terminated. So what I mean to say over here is, suppose we were having a parent process as P, we were having the child processes as P1, P2 and P3, and we were having some more children processes of these P1, P2, P3, let's say they were, let's suppose we name them as C1, C2, C3, C4, and so on. Let's suppose C5 is of P3. What happens in this case if P process P terminates? So if a process P terminates, It is the operating system which will not allow any of these child processes. So basically, over here, P1, P2, P3 are the child processes of P, whereas C1, C2, C3, C4, C5 are the grandchild processes of parent P. But if parent P is no more in existence, the OS basically will initiate the process to terminate all the childrens which were there of this process P. Fine, so they all will be terminated. And when a process terminates, its resources are deallocated by the operating system. That means whatever resources were held by this process P, they all are deallocated by the operating system, and the resources are now part of the central pool where they can be used by other processes. The parent process has invoked a wait system call by means of which it will wait for all its children processes to terminate first. That is, whether the termination is abrupt one, means by means of abort, or whether they have terminated because they have done their job. So the parent has invoked a wait system call on themselves. That means till the time all the children processes have terminated, then only the parent process will terminate. So to summarize over here, the process can be created using a system call named as fork, whereas the processes can execute by means of system call that is exec. And the third thing is process termination. In case the termination has to be done priorly, so for that we are having another system call that is abort, or the processes may terminate because they have completed their job. So in the next slide, now we'll be discussing about inter-process communication. So yes, uh, interprocess communication, or IPC, refers to a mechanism where operating systems use or facilitates communication between different processes. So, for example, in a multitasking environment, number of processes are running concurrently, and inter-process communication allows the processes to exchange information, and due to this they can basically coordinate amongst their actions. Further, the processes that are executing may be either independent or they may be cooperating processes. As far as independent processes are concerned, they do not share data with any other processes executing in the system. Whereas the cooperating processes basically uh, uh, is affected by other processes which are running in the system. For example, if a data is shared by any process, then that process is a cooperating process. Now the question arises, why processes cooperate? So the very first thing is information sharing. Many processes might be interested in same piece of information, for example, copying and pasting some information, or a word processing software may need to pass data to a printer to generate a hard copy. So over here, what I'm saying is, data is a set of data is transferred for printing by a word processing software. So on the one side we are using word processing software, on the other hand we are making use of printer, and data is being transferred uh, from the word processing software onto the printer to get its hard copy. So likewise, so in this there are few processes which are involved, so there needs to be some sort of communication. Then the next thing is computation speed up. So if we want to do a task faster, so in that case we can divide the task into multiple smaller subtasks, and all these smaller subtasks can be executed parallelly. Obviously, in this case, the computation will be speeded up. Then comes the modularity. So suppose we are constructing a system and we want to do that in modular fashion, which means that we are dividing the system into multiple smaller subparts depending upon their functionality. And these division the dividing of this system functions is done into separate processes or maybe in threads also. Then comes the convenience. So suppose even the individual user may work on multiple tasks at one point in time. So for instance, a user might be printing, he might be editing, he might be compiling, and all these things are done in parallel. So that is the reason why we need to have corporate processes. So cooperating processes basically use IPC to exchange data, that is where they can send as well as receive data. This is done by means of shared memory as well as message passing. Now as far as message passing is concerned, in message passing, processes exchange data by sending and receiving messages. In this method, or I would say this method is particularly useful for interprocess communication in distributed systems. When a process sends a message, it specifies the recipient ID and the contents of the message. So let's suppose that there's a packet where the message is being stored and it is mentioned on that packet that for whom this packet is for. That is, the recipient's ID is mentioned over there. So here the operating system is responsible for delivering the message to the recipient process or to the receiver. Message passing also has a disadvantage where there is an overhead, because we need to copy data between different address spaces. For example, uh, from the sender side, data is being transferred onto the receiver side. So from sender's address space, data is being copied onto the receiver's address space. And there is a possibility that during the transfer of data, the message may become corrupt or the message may lost due to the failures in the network. Fine. So if we talk of the other category, that is shared memory. So here the processes communicate by means of sharing a common memory region where multiple processes can access the same data in memory. So there's a common region. The OS creates a shared memory region and each of the processes can write into this region as well as read from this region. But there is one limitation in this, because data is residing in the one because there is a common address space over here. So if we compare this with the previous method, that was message passing, so we had a limitation because data was copied from one address space, that is from sender's address space to the receiver's address space. That limitation is overcome over here in this shared memory, because we are having a common memory over here, and we need not to copy data from one place on to the another, but the data is residing at a common place and number of processes can access this common shared memory and can make use of that data. But then there is a limitation of this, that is we need to have a synchronization amongst the various processes that are accessing the common shared memory. So what I'm trying to say over here is, suppose there was one process who was trying to write some data into this common shared area. At the same time, some other process was over there who was trying to read the data. So if you see over here, this will lead to an inconsistency of data, because at certain locations in this memory, data is both read as well as written simultaneously, and this will result in some inaccurate kind of a scenario, because of data inconsistencies. So we need to have some mechanism where this shared area of memory can be accessed in such a way that we can overcome the data inconsistencies. So this is how interprocess communication takes place, and it is the operating system basically which assists in providing this interprocess communication. So that's all with regard to this lecture. Thank you.